Hello, Assalamualaikum. Today we want to talk about presentation 2 for DJJ 52012 Engineering Plant Technology. Okay, and my group member is first SHARIZAN F1110, and second Muhammad IMRAN NABIL B IBRAHIM F1111, and then Muhammad Syami bin AZHAN F1112, Muhammad ALIFF HANIF bin BAHARIN F1113. We want to talk about the topic intercooling gas turbine cycle, reheat gas turbine cycle, generation gas turbine cycle. Okay, for the introduction, intercooling gas turbine cycle. Intercooling is the process of cooling air between two phases of compression with a decrease in thermal efficiency. This decreased compression work and boost plant specific output. Intercooling efficiency loss can be recovered by using exhaust heat exchange in a reheating cycle. Reheat gas turbine cycle. Reheating the gas after it has expanded in a portion of the gas turbine is a popular method of improving the mean temperature of heat reception. As a result, the mean temperature of heat rejection rise, lowering the plant's thermal efficiency. Reheating, on the other hand, boosts the plant's particular output. Okay, next. Regeneration gas turbine cycle. The thermal energy remaining from the exhaust gas leaving the gas turbine is used in the regeneration process. This can be achieved by using a shell and tube heat exchanger to transfer heat from the hot exhaust gas from the gas turbine to the compressed air from the compressor.
Now I would like to explain about working principle of intercooling, reheat and regeneration gas of turbine cycle. Firstly is intercooling gas turbine cycle. Thermodynamic process involved in multi-stage intercool compression. First stage compression occur in low pressure compressor, which are LPC, and compress air leaving LPC at 2 descent to intercooler, where temperature of compressed air is lowered down to state 3 at constant pressure. Intercooler is a kind of heat exchanger where heat is picked up from high temperature compressed air. Next is reheat gas turbine cycle. In order to maximize the work available from the simple gas turbine cycle, one of the options is to increase enthalpy of fluid entering the gas turbine and extend its expansion up to the lowest possible enthalpy value. Then also can be said in terms of pressure and temperatures value that is inject fluid at high pressure and temperature. Next, for future increasing in net work output, the positive work may be increased by using multi-stage expansion with reheating in between. Last one for reheat gas turbine cycle is reheating another combustion chamber may be used. Lastly is how the regeneration gas turbine cycle working principle. A regenerator, which are counter flow reheat exchanger through which the hot turbine exhaust gas and comparatively cooler air coming from compressor flow in opposite direction. Under ideal condition, no frictional pressure drop occur in either fluid stream while turbine exhaust gas get cooled from 4 to 4 while compressed air is heat from 2 to Z. That's all from me for working principle.
Assalamualaikum, my name is Muhammad Syami bin AZHAN, metric number F1112.
I will share about diagram of figure. Now we go through to the diagram of intercooling gas turbine cycle. The cooling of air between two stages of compression is known as intercooling. This reduces the work of compression and increase the specific output of the plant with a decrease in thermal efficiency. Multi-stage compression with intercooling improves the efficiency of a compression process. Next, we go through to the Brayton cycle with intercooling. A Brayton cycle with intercooling uses two or more compression stages with one or more intercooler. As shown below, the power requirement for compression is reduced, but QH also increases. Okay, now we go through to the diagram of regeneration gas turbine cycle. As the diagram below, we can see regenerative is a thermodynamic process that utilizes the remaining energy in the exhaust gas from the gas turbine to heat the air entering to the gas turbine. This process can be made by heat exchange between the exhaust gas and compressed air by utilizing shell and tube heat exchange.
Summary. Number 1. Intercooling is the process of cooling air between two paths of compression, which a decrease is termed efficiently. This decreased compression work and boosts plant species output. As a result, a technique known as multi-stage compression with intermediate cooling is used, in which gas compression stage and cooling and to an initial temperature between each step by passing it through AZHAN. Number 2, regenerative combustion is a thermodynamic process with a leftover energy in a gas turbine exhaust. Gas is used to heat the air that enters the turbine. Heat exchange between the exhaust gas compression air can be accomplished using a shell and tube heat exchange. The regenerator raises the temperature of the air that enters the burner, lowering the fuel to air ratio and improving adiabatic thermal efficiency. Number 3, reheating is a technique for raising the average temperature of heat recipient. The gas is warmed after it expands in a gas turbine. In the scenario, the Brayton cycle is which compressed air is mixed with fuel and burned under constant pressure conditions. Is used in a gas turbine to perform the operating. The host gas allowed to expand through the turbine. The compressor, the burner, and the power turbine are the basic components. Conclusion. It is possible that the conclusion that an ideal intercooler cycle always yields poorer thermal efficiency than a short cycle gas turbine is unsustainable. Intercooler can that extend thermal efficiency when compared to simple cycle gas turbine. When eventually it takes into account the steam is expanded to intermediate pressure and reheat in the boiler to minimize and increase a mountain in the steam going out of the turbine. It has been discovered that adding regeneration to a simple gas turbine cycle improves the cycle thermal efficiency. It was also discovered that incorporating regeneration into a gas turbine cycle increases the cycle output power while also lowering the exhaust gas temperature. The gas turbine cycle efficiency should improve as a result of this. Increase the temperature of the turbine inlet in the turbine material can survive it, or if someone has access to the spare part that can withstand it. Increase the pressure ratio as well, depend on the temperature of the turbine inlet. The efficiency increase has a limit.